Hi, we are so excited that you're joining us. Today we are looking at another problem of the week. It is so exciting to see what students can do when they're actively engaged in problem solving and learning new strategies. So, are you ready? Let's get started.
Problem of the Week, Episode 2, Flagpole Problem. This week, we're looking at a problem from 4th grade Problem of the Week, 4th grade Set A. I am very excited to look at this with you. Now, these sets were designed for a school-wide initiative, but you can use them in so many ways. So I hope that they will be helpful for you in your classroom. What's important about this problem? I want us to take a look at the problem and evaluate whether or not it's a good problem to use with your students, and how can you evaluate any problem-solving task to make sure that it's truly a problem-solving task and not just a worksheet with words. So, 3 men are putting a new flagpole in the ground. 1/4 of the pole is buried in the ground. The height of the flagpole that can be seen is 12 feet. What is the total length of the pole? As we discussed last week, one common mistake, and we've trained students to think this way, is to take all the numbers in the problem and just do something with them. So immediately some students will say there's only one number, it's 12. Well, once they read it, they'll understand, okay, well, it's actually 3 is a word that is a number, 1/4, and 12. And if you look at keyword total, some students will just say 3 plus 1/4 plus 12. But all of them, a common misconception would be to take all of those numbers and do something with them. And we can see that that doesn't work. So that's good. We want problems where students can't take that common mistake of just taking all the numbers and doing something with them, and then they'll have a correct answer. Because if students do that, we can see their misconceptions. So what should you expect? Do you think most of your students will solve this problem accurately the first time? Probably not. And that's okay. We want to give students problems that really cause them to stop and think and build their perseverance and build the strategies that they have to make sense of problems. That's the goal. Perseverance is so important, and we want to give students strategies, but we also want to change their mindset. It's great if you don't know how to solve a problem because you're going to learn something new. In the Problem of the Week series, detailed solutions are provided that can be shown directly to students. Why do we do this? And what if students solve it a different way? I think it's really important to point out to your students that this is one way. The problem says that too. If you look, it says one way to solve the problem is to draw a picture. You can talk to your students, what are other ways? But the picture really does help them understand and make sense of the problem. And you can see it tells you what you did, why you did it, and you've got your illustration. It has an equation that is labeled. I can talk more about that later, but I think that's very important. And then it has the answer. Now, you'll notice that these equations don't involve the fraction itself because this is geared toward 4th grade, and they have not yet studied computation with fractions at this point in the year. So that's okay. And if your students are older, they may solve it a different way, and that's okay too. And then we always make sure we celebrate, whether it's school-wide or in your classroom. We did it on morning announcements, and so we would show pictures of one student's work, and then we would have a winner. And the winner was chosen randomly from the correct answers, and then that student would get an ice cream from the cafeteria. But it was just a fun way to celebrate and to get students involved. Let's look at this student work sample. The student has the correct answer. They're able to tell you that the flagpole is 16 feet. Their drawing is accurate. They've got 1/4, 2/4, 3/4 above ground, 4/4 underground, and it's labeled buried underground. And they have the number of feet labeled correctly. So what is not correct? If you read their writing and if you look, and these are all scratched out, but there's some here too, their computation, the way that they've represented their thinking through computation is not correct. So this student already has a strong basis because they conceptually understand the problem. They're just not able to correctly represent it mathematically. So now you know how you can help that student improve. But it's exciting to see that they are drawing the picture and understanding the situation. Here's another work sample. The total length of the pole is 16 feet because 4 plus 4 plus 4 equals 12, but you still have 4 left. So that means we have to add 12 plus 4, and that is 16. And once again, the picture is great. You've got 1/4, 1/4, 1/4, and 3/4 here and 1/4 here, and then each of the fourths has the quantity inside 4, 4, 4 for 12 and 4. So all of this is okay, but let's look at that equation. 12 plus 1/4 equals 16. So how can we help that student? We can help that student by talking about what are you doing? This is in feet and this is parts of the pole. So you can't really add those together. You could say 12 plus 4 equals 16, or 3/4 plus 1/4 equals 1. But really just helping this student once again communicate through mathematics their understanding. So the understanding is there, which is great. And this is an easy thing to do through modeling and discussion. This student really is doing off to a great start, but this does help you to help them. Let's look at another sample. For this student, I enlarged the picture so that we could really examine it. I love the way it's labeled. It's got the fractions on the right side, 1/4, 1/4, 1/4, and then 1/4 underground. It's got the quantity or the length on the left side. So you can see 4, 4, 4, and then you see the 4 feet underground, and it's got a sentence with the answer, and it's got an equation. So what I would say is this child has a good understanding of the problem, just as previous students. It's set up. I'd like to see a little more communication. So one of the things that you might be able to do is really help this child. How do you better communicate what you're thinking? And what are other equations that you could write? Because the whole goal too is to set up students for success later in building those strategies. We're going to talk more about that next week. But off to a great start, and you know how you can help. Pause for just a moment and look at this work sample. What do you think the student understands, and how could you help the student? When I look at this work sample, the student has a conceptual understanding of the problem. The label looks good. They've shown their thinking through equations. The only thing I would really focus on at this point in 4th grade is labeling your equations, maybe communicating a little more clearly, even though it's good. The student's done a good job. You're not going to expect computation with fractions in 4th grade. If you're using this with older students, you might. But the student's done a good job. There are still ways to improve, but overall, good thinking. This is a great work sample. Let's look at what we like, and are there any ways that we can help the student? One thing I really love is that the representation is horizontal. So you can tell this student has moved away from having to make it look like a flagpole. They've just got their bar and it's divided into fours and it's labeled buried, shown, shown, shown. So that is a more advanced representation because it doesn't really have to look like a flagpole. I love that the student has labels on their equations and the explanation is strong. The only mistake that I see on this is 1/4 plus 1/4 plus 1/4 equals 12 feet. And I can tell the student knows what they're doing. And I realize that in 4th grade, computation with fractions is new. So this would be a great opportunity to just ask, is 1/4 plus 1/4 plus 1/4, what does that equal? Does it equal 12? How could you have better represented this with a computation? But great job. This was really encouraging to me when I received this work sample because this student is working from home. So that's fabulous. Let's look at this work sample. Once again, the representation is horizontal. It's labeled. This is in the ground. This is the part that's 12 feet. One thing I really love is it's got 4 feet times 4 sections. So it's not trying, this student's not trying to use fractions in the computation. They're labeling them as sections instead. And I love this, 12 feet divided by 3 sections equals 4 feet in each section. So this student really has a good conceptual understanding of the problem and communicated that really clearly. Great job. Here's a copy of the problem, and if you go to Google Slides or go to our website, you'll get a copy where you can download Google Slides and you can try it. I would love for you to try this problem, and please send us student work samples. Speaking of student work samples, a special thanks to Carol for using Problem of the Week series with the school and sharing recent work samples with us. We are so appreciative of having these samples to share with you. So most of these samples were from her. Some of the work samples in the series are from my past experience with students. But once again, thank you so much, Carol. We really appreciate you. And we are glad that you're using this series. And a big thank you to all of you. Once again, we so appreciate your time and we value your thoughts. So much so that we are giving away free prizes every month. So we hope you'll enter using one of these ways. And perhaps you'll be the winner this month. We hope so. Also, don't forget to hit like and subscribe. We don't want you to miss a single episode of Mind Bending Monday. So thanks again. We loved seeing you this week and we look forward to seeing you next Monday. Have a great week.